What is net force when multiple forces act on an object in GED physics? Imagine you're pushing a shopping cart in a grocery store. Sometimes you push from behind, sometimes you pull from the side. All these pushes and pulls are forces acting on the cart. But how do they work together to move the cart? That's where net force comes into play. Net force is the overall force acting on an object when you combine all the individual forces. Think of it as the total push or pull after considering all the forces involved. Since forces have both size and direction, you can't just add them like numbers. Instead, you treat forces as vectors, which means you add their sizes while paying attention to which way they point. When multiple forces act on an object, you add them up by considering their directions. For example, if two people push a box from opposite sides, the net force is the difference between their pushes. The stronger push determines the direction the box will move. If forces are at angles, you break each force into parts called components, which are straight lines in specific directions. Then you add these components to find the total force in each direction, and from there, you can find the net force. The size of the net force tells us how the object will move. According to Newton's second law of motion, the net force causes acceleration, which is a change in speed or direction. If the net force is zero, the object won't change its motion. It will stay still or keep moving at the same speed in a straight line. In everyday life, understanding net force helps explain many situations. For example, when you push a heavy box, friction and your push combine to determine if the box moves. If your push is stronger than friction, the box will accelerate forward. If not, it stays put. When objects fall under gravity or are pulled by tension or friction, net force helps predict their motion. So, to sum up, net force is the total force after adding all forces acting on an object, considering both how strong they are and which way they point. It tells us whether an object will speed up, slow down, or stay at rest. Calculating net force involves adding forces as vectors, especially when they act in different directions. This idea is key in GED physical science because it explains how forces combine to influence how objects move in the real world.